trying to do in a nutshell is to build a quantum computer with light. Make measurements of light both as an electromagnetic wave and as light particles, also known as photons.
Quantum computer is revolutionary because it improves the data security, and it can also provide exponential increase of calculation power, such that we could have a lot of scientific discovery in many fields.
So the goal of this experiment is to produce this quantum state with just one light particle or photon. And you can use these sort of quantum state in optical quantum computing. Now, how do we produce this quantum state? We use this phenomena called spontaneous parametric down conversion, and what happens there is you have one high energy photon, in our case it's a green photon, and it goes through this special type of crystal and it gets converted to two lower energy red photons. Now these two red photons, they travel through two different paths. When you measure one of the photon, you are 100% sure that there's a photon on the other side of the experiment, and that's how we produce these single photon state, which are further characterized by this detector called transition edge sensor.
We use a specialized device that counts these photons, and it must be kept colder than the temperatures of outer space. At this temperature region, the energy from each piece of light changes the way the device works so that we can see a proportional signal on the output screen. These signal tells us how many photons were absorbed at any given time, anywhere from 1 to 5 photons.
When making any computer, you need a resource where all the information is encoded, something you can manipulate to perform your computer code. For the type of quantum computer we'd like to make, our resource is called a cluster state. In one of our cluster states, each dot is a different color of light, and each line connects two colors through a process called quantum entanglement. Connecting a lot of these colors makes a cluster state. A bigger cluster state means I can tackle bigger problems with my quantum computer.
The dots in the cluster state mentioned before are actually selected by an optical cavity. However, if there's no such selection process, there will be much more dots which can construct even bigger cluster states. Then what will happen? We are still exploring it.